This is your project base paper, which I explained you earlier. The same thing. Actually, in your projects, we are detecting the cyber threat. Okay. On industrial internet of things. So I'm just explaining about your base paper with your concepts. So as per your base paper, they are implemented with the part of federated SVM and federated XGBoost as a outcome. Okay. And they are using nearly 6 ML algorithms, which I'm presenting you right now. So you can see here MLP XGBoost. So these are all the ML classification algorithm with federated SVM and federated XGBoost algorithm we are using over here. And these are all the attacks which is affected by using cyber attack on industrial things. Okay. And then finally, we are classifying what types of model. So here we are having two types of learning. One is centralized learning and another one will be federated learning. So here we are having this many models. By using centralized learning, we are nearly applying 5 to 6 algorithms. And by using federated learning, 2 algorithms. So you can see here the implementation of the training part. So first we imported the packages and then we imported the data set. And finally, we can show how much based on the classes for each algorithms. So these are all the things for EDA. That is, we are doing exclamatory data analysis part for each classes, for each threads. So nearly we applied all the algorithm. Apart from the base paper, we are using KNN, XStar tree, and decision tree, random forest. These are all the algorithms. It's not available in your base paper, but I had add over here these many algorithms. And finally, we are classifying the classes low, medium, high, and very high. So this will be the outcome of final for all algorithms. This is for random forest and decision tree. For all the algorithms, we are presenting confusion matrix and ROC curve. In your base paper also, they are presenting the same thing. And finally, bar graph for all the ML algorithms. That is for centralized algorithm. And furtherly, we are using federated learning SVM with XGBoost. So these are all just a warning, not an error. You no need to consider these are all an error. So in a federated learning with the SVM and gradient boosting, we are using number of rounds will be nearly for each client 0, 1, 2, 3. Nearly 3 clients for each rounds. And finally, we are getting 0.85 accuracy and we improved over there nearly above 0.9% accuracy. So this will be the web app of your application. So here you have the process for registration, login, and once we register and login, you have the feasibility to predict the cyber threat which is available on industrial IoT. So this will be the simulation that I just created and a simulation. Based on that, it will show whether it is shield status, security level. Okay, so just I'm starting for the registration. So here I just intimated nearly upload the data set and select the model and detect the thread. Okay. So you have the feasibility to upload the data set, and you have the feasibility to select the model, that is centralized learning with five more algorithms, and federated learning with two more algorithms. And finally, you can detect directly, not from the data set, you can directly give the values and you can predict the result. So you can see here we are uploading the data set. So we can upload any data set over here and we can predict the result. So right now I had uploaded the data and I have to select the algorithms. So you can see here it's showing what type of attack it is, prediction will be. And you have the feasibility to predict your direct values also. And it will tell what will be the prediction also. Again, I am uploading some data, some different data, not the same data. And I uploaded the data and I'm selecting some other algorithms and I'm predicting. So it will show according to the data set. And here also you have the feasibility to detect. So finally, threat detection here. So if you predict, it will tell what will be the sample is accordingly.